So today we're going to cover the second half of section 6.1, which is continuing our properties of exponents. Remember, our goal today is to be simplifying exponents. So we're just going to jump right in. We have a few new rules today. One of them is a power of a power property. And as we did yesterday, we want to know it in words and in symbols as well. So this one says in words, if we see a base with an exponent that is raised to another exponent, we'd keep the base the same and then multiply the exponents. So let's see how that works down here. And before we use the rule, I'm always an advocate of making sure we know that if we forgot the rule, we could always expand it and ask ourselves, if I had to write everything out, how many times would I write that base of z? So what we see here is that if we have something being squared, we would need to take that something and multiply it by itself twice. And then the question becomes, well, what do I put in those boxes? What am I doing twice? Well, I would write z to the third power. And then from there, well, I know what z to the third power is. That's just z times z times z. And then just continuing that multiplication. And then over here, z to the third is z times z times z. So how many times did I just write z? Well, 1, 2, 3, 4, 5, 6. So this answer, I know, is z to the sixth power. Now, if we're using the rule, what it's telling us to do, if I see that z, this base, has an exponent of 3, the answer would keep that same base, z, and I would take this exponent, 3, and I would multiply it by the outside exponent of 2, and that's where I got the 6 from. So let's go write that in symbols. So in other words, if I have a number, I don't know what it is, so I'll just call it a, raised to some other power, so that could be any number, and I see that that entire thing is raised to another power. What I do is I keep the base the same, and I multiply the exponents. So we have another example over here, x squared all to the negative third power. So I see that I have a base raised to an exponent, all raised to another exponent. So to simplify that, we would keep the base, so the base is x, and I would multiply the two original exponents. Now you'll see here that that gives us a negative exponent, and we know what a negative exponent means. It means send it to the bottom if it's on the top. So I put it over 1 so I could see that x is on the top, and then it would move to the bottom. So we'd simplify it like that. So like a good note for today that we could add to the side in your notes that I would want you to see when you turn it in to me, is to make sure to use all the rules to simplify. And we're going to say that, simplify completely. We know from our day 1 notes that we don't want any negative exponents. So that is our power of a power property. So here we have a product to a power property, and in words what it says is if a product is raised to a power, find the power of each factor and multiply. So you see in the margin here that I defined that word factor for you if you were unfamiliar with what factor meant. And all the factor is, it's just one of the numbers in a multiplication problem. So for example, I wrote down here 2 times 3 was equal to 12. So 2 and 3 are factors because of the things that were being multiplied. Now that is the actual way that we'd write it in words, and that's great, and I want you to memorize that, but sometimes it's also nice just to know what does it mean in usable terms. So the way that I remember a product to a power is what I wrote below it. If I see a bunch of things being multiplied all inside one set of parentheses, kind of like right here, I see 3 and 2 are being multiplied inside a set of parentheses. And then I notice that that parentheses, that whole thing is raised to an exponent or a power, like it is 2. What this rule tells me is each individual thing gets that power. So let's break that down for a second. So again, here we realize that there's a bunch of things being multiplied inside a set of parentheses. Now, what are those two things? One of them is 3, and the other one is 2. So what this tells us is that each of those factors, or each of those things that's being multiplied, gets the power of 2. So this would simplify. I know 3 squared is 9, and 2 squared is 4, so this would be 36. And it's nice to note that we could just use our order of operations to verify that, right? If I was going to simplify this, our order of operations, parentheses come first. So I'd simplify inside parentheses. 3 times 2 is 6. 6 squared we know is 36. So let's look at one that's a little bit harder. So here we have 2 things that are all being multiplied inside one set of parentheses, and we can see that set of parentheses is raised to an exponent. So the 2 things that are being multiplied, one of them is x squared, and the other one is y to the third. So we rewrite those things. So x squared is one of the things, y cubed is the other thing. Now they both should get that power. Now in the margin here, or somewhere above maybe what you need to write is use parentheses. Meaning these two things here, I should put a set of parentheses around it because that thing should get the power of 2, the original exponent here, and this entire thing should get the power of 2. And the reason we need to use parentheses is because then we can see that we would use our power to a power rule, right? I see a base with an exponent raised to another exponent. So to simplify that, we would multiply the exponents. So this is x to the 4th. And then here we'd repeat that process. I see that we have a base to an exponent raised to another exponent. So to simplify that, we multiply their exponents. So our final answer then would just be x to the 4th times y to the 6th. And we'll have one more example here, just so we can see it doesn't matter how many things are all being multiplied, right? Here I see that a is being multiplied by b squared, and then it's also being multiplied by this quantity c cubed. Now that entire parenthesis, right, this entire thing is being raised to the power of 4. So that means each thing, so a, and we like to put each thing in parentheses, and then b squared, and then c cubed, each of those things gets the original power on the outside, which was a 4. Now we can use our power to a power rule, right? This is a to the first power to the 4th, so we'd multiply 1 times 4, and that is the final exponent on our base. Here we do 2 times 4 because we have a power to a power that we learned above. It's b to the 8th. And here we have a power to a power, so 3 times 4 is 12, so we'd keep the base and multiply the exponent. So that's our final answer there. So the last thing we'll do is fill that out in symbols. So we do it in symbols. If we had two things like a and b being multiplied, and they all get a power of m, the way that we would simplify that is the first thing gets its own set of parentheses, the second thing being multiplied get its own set of parentheses. We connect them with multiplication, and each of those groupings gets the exponent of m. So another rule that we have today, this was things being multiplied, all raised to a power. This one is the quotient to a power. So in other words, if a quotient is raised to a power, we find the power of the numerator and the power of the denominator, and then we divide. Or in other words, what I like to think about like in a usable way is if I see an entire fraction inside a set of parentheses, and that like kind of like I do down here, I guess I would say like right here, I see this fraction is inside a set of parentheses, right? And that entire set of parentheses is raised to a power. Then what it's telling me to do is the numerator gets that power and the denominator gets that power. So the way that I interpret it down here is the numerator is x, the denominator was y. So that means the numerator gets the power, so x gets the power, and then the denominator gets the power by itself. And that's all we would simplify that. Now, just like before, when we used our product rule, we want to use parentheses. So we're going to write it in symbols right away. So if I see two things like a being divided by b inside a set of parentheses, then the numerator in its own set of parentheses, that whole fraction is raised to a power. The numerator in its own set of parentheses gets that power, and the denominator in its own set of parentheses also gets that power. Now, we're going to jump to the example on the right to see why that's important. So here, I do see an entire fraction, 2x divided by 3, and that entire fraction is being raised to an exponent. So I'm going to use my quotient rule. So what it says is the numerator, which is 2x, I'm going to write, right there. The numerator gets that power, and then the denominator, which is just 3, that also gets the power. So the denominator, 3 to the negative 5th, that's very clear to us. But if I just write this, 2x to the negative 5th, that is wrong, because here that would make it look like only the x is getting the exponent, but that's not true, right? The 2 and the x were supposed to be raised to a power. So that's why we need to include parentheses. So here we see some negative exponents. So we know negative exponents mean move the location of the base. So this 2x was on top, so now it's going to go to the bottom. And then this 3 to the negative 5th was on the bottom. So that's also going to move to the top then. And after we move, we get positive exponents. So here, 3 to the 5th, we can just leave as 3 to the 5th for right now. But on the bottom, we see that we have a product. So, right, we have two things being multiplied, all inside a set of parentheses. And that parentheses has a power on the outside. So we can use our product to a power rule, right? The one that we just went over. It says the two things being multiplied, each of them gets the power inside a set of parentheses. And then we simplify. So I'd put 2 inside a set of parentheses, and I'd put x inside a set of parentheses, and we'd simplify. So 3 to the 5th over 2 to the 5th times x to the 5th. And we'll leave it at that for right now. We won't expand 2 to the 5th, although we know that 2 to the 5th, if we needed to, 1, 2, 3, 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So if the directions or your teacher wanted you to expand that further, we could do that. So what's really nice about those two, when we use the quotient and when we use the product to a power and the quotient to a power rule, we really need to use parentheses a lot. Now, the last thing I'd want to say with those parentheses is making sure that we know to use parentheses when we work with negatives, right? So we need to pay extra attention when we work with negatives because in many cases we need to write a set of parentheses to indicate what's getting the power and what's not. So these two examples will be our focus today. And what I want us to see here, the negative is inside the parentheses, and here the negative is not. Now, there's two ways that we can think about this. Here, I see -2. Everything is inside a set of parentheses. So when I see 6, I'd have to write something 6 times. And what am I writing 6 times? Well, this thing -2. So I can see there that if I multiply these, this is 4 times 4 times 4, which is 64, right? Now, another way I'd ask us to see that is using our product to a power rule. -2 is the same thing as -1 times +2 to the 6th. So if I used our product to a power rule, the first thing would get its own parentheses in the power, and the second factor or thing would get its own parentheses in the power. And -1 times itself 6 times, right? A negative and a negative and a negative and a negative, negative and a negative. That's just a bunch of positives. So this is positive, and 2 to the 6th is 64. Now, with that, what we can see here is if I rewrote this would be rewritten as -1 times 2 to the 6th. And right now, the way that I would expand that is because there's no parentheses, this exponent is only applying to the 2. In other words, the character or the base that's directly next to it. So this would I'd have to write out a bunch of 2's, 6 of them, but I'd be writing 2's. So here I get -64. So where we put the negative, we can see is a big difference as to what's being repeated. Here, 2 was being repeated, and the negative was just in front, whereas here, the negative was being repeated every single time. So when you rewrite things, here, like when I see that there's a product, and I see -2 times x squared, I have to use parentheses around the -2 to the 4th, because if I don't, right, this is supposed to be positive 16, right? If I did -2 times -2 times -2 times -2, that's a bunch of positives because negatives and negatives cancel positives. But if I write this is actually -16. So without the parentheses, I'm wrong. Right, so this is 16x to the 8th. Same thing over here when I'm using this fraction. -3 on top, that entire thing is supposed to get the negative exponent. So without the set of parentheses, we would be wrong. So everything is going to flip because of the negative exponent. And then we could just simplify. But notice how that negative moved to the bottom as well. Same thing here, the negative is inside the parentheses. So when I use my power rule, or the product to a power, I have to put the negative inside the parentheses as well. Otherwise, we're going to get, right, a negative to the 4th power, negative times negative times negative times negative. That should be a positive. Without that, we would be wrong. And that's our notes for today.